Hi everyone, this is Fahad Mirza and I welcome you to the channel. Automating handwritten signature detection is a challenging yet crucial task in modern document processing workflows as handwriting intricacies, varied orientations, noise, and complex document layouts can greatly impact accuracy. To address these challenges and enhance automation efficiency, an open source handwritten signature detection model has been carefully developed, integrating state of the art object detection architectures. This approach combines efficient CNN based detectors from YOLO series as well as transformer based architectures such as Data and YOLOS to capitalize on both high accuracy and computational efficiency. We are going to install this model locally and we will try it out on few of the documents to identify human signatures. Before that, let's talk a bit more about this model. A key foundation for this model is the hybrid dataset meticulously curated by aggregating two publicly available collections. This dataset incorporates a diverse and comprehensive set of handwritten signatures captured under various document styles, backgrounds, orientations, and conditions. The dataset's diversity allows the trained models to generalize effectively, greatly mitigating typical real world risks such as signature cropping, noisy backgrounds, complex overlapping layout, and broad handwriting variability. Let's try to install and we will test it out. Let me also give a huge shout out to Mast Compute for sponsoring the VM and GPU for this video. If you're looking to rent a GPU on very affordable prices, you can find the link to their website in video's description. Plus, I'm also going to give you a coupon code of 50% discount. This is my VM and this is my GPU card NVIDIA RTX A6000 with 48 GB of VRAM. Let's start by creating a virtual environment with Conda. And now let me install all the prerequisites which include torch vision and other stuff. It is going to take a couple of minutes, and while that happens, let me also introduce you to the sponsors of the video who are Camel AI. Camel is an open source community focused on building multi-agent infrastructures for finding the scaling laws of agents with applications in data generation, task automation and world simulation, and I will also drop the link to their website in video's description. All the prerequisites are done. Next up, let me take you to my code directory where I have put in the code in order to run this model. Okay, let me show it to you in my VS Code and then we will proceed. So this is a code which you can also obtain from their model card, but I have just added some Gradio elements to it and we will be launching it in our browser. So all I'm doing, I'm importing some of the libraries, I'm specifying the checkpoint, here the model, putting it onto the CUDA device, getting it with the tokenizer, and then we are just grabbing the image whatever user will upload, annotating it, and then using the model to identify the signature. Okay, so let's go to terminal and let me clear the screen and let's launch this in our browser. Let me run this. And there you go. The first time we have run it, it has downloaded the model. It is a very small model, and then we are going to access it in our local host at port 7860. And there you go. So it is running here and it comes with some of the examples. So let's run maybe this example. I have clicked on it. It's very fast. It's running on CPU, by the way. There is no GPU. I am more than sure. So let me quickly check. There you go. It's all running on CPU because there is no GPU occupation at the moment. So look at this. This is a document on the left hand side and it has identified the signatures on the right hand side. So there are a lot of good examples there. For example, look at this. Again, it has identified this signatures very quickly. Sorry. So there are two, this and that. Very nice. And there is also handwritten this one, but it didn't take it as signature. Pretty cool. And then let's check this example. Again, you see it's not that clear, but it was able to do so. And then you see the other one, the first at the top third line could be mistaken as signature, but it is not. Well done. And now let me try out one of my own image. So I'm just clicking on this X. Let's click here And I'm going to images. I have this folder sign. I'll just pick up this AI generated image, and then I'm just going to click on detect. There you go. See how quick that was, and it has correctly detected it. Very nice. Okay, let's try out another one. So I'm just going to go with sign 2. I just jumbled up these images quickly. There you go, magic. So very impressive. Really like it, and you can embed it in your pipelines. For example, if you can even build an AI app which would do the signature matching, stuff like that, and then you can just use a vision model to do that. There are a lot of use cases around it. One more thing which I wanted to mention about this model, which I really liked, was that to select the best performing, model, I would say, when they were doing the training, they also did comprehensive architectural benchmarking that evaluated several other detection frameworks, including YOLO variants, DETR, and YOLO's architectures. And by the way, we have covered all of them on the channel previously. And then their rigorous experiments involved comparing accuracy, computational requirements, inference speed, and deployment. Also, to further enhance models' performance, hyperparameter optimization was conducted using the Optuna framework that also yields really significant improvements I have seen. And their F1 score was also quite impressive if you check out their model card. So, this optimization effort was instrumental in achieving an ideal balance between the precision necessary for robust detection, as you just saw, and the recall required to minimize missed signatures. Also, recognizing the practical necessity of deploying optimized machine learning models in production with minimal inference latency, they have selected Triton Inference Server combined with OpenVINO CPU optimization. But even I'm not using OpenVINO, but you just saw that how quick this thing is. So as soon as you select it and click on that, it does a fabulous job, as we saw. Now, for example, look at this document, is not that clear, but still it is able to detect the signature. I mean, this almost looks unreal to me. So very impressive stuff. I think I'm going to use it in few of my use cases. So, but let me know what do you think about this model. I will drop the link to it in video description. This signature detection is really mind-blowing in my opinion, without any hype. If you like the content, please consider subscribing to the channel. If you're already subscribed, please do me a favor and share this among your network, as that is the only marketing I do, and I rely heavily on you guys to do the marketing. So thank you very much, and thanks for all the support.